Hey guys, today we're going to talk about upgrading your batteries on your RV. It'll make them last longer, it'll get you through a hard time if you're stuck somewhere, broken down, or have to stop overnight and you're running appliances, or in my case, you're running a small inverter to keep your refrigerator going. It's critical to upgrade your batteries. Stay tuned and I'll explain to you why. So when you picked up your RV, they probably put some kind of junky, basically car battery or marine battery in it to get you home. The bottom line is, this isn't really rated for actual deep cycle service. Now, as far as these type of batteries go, this is actually a little bit better than most batteries you'll see coming off the lot in an RV. This is actually an AGM, which kind of surprised me they put this in my rig, because the conventional standard single phase chargers, converter chargers that are in these units really aren't designed to charge an AGM battery. That aside, it's a better battery than normal, but it's still not a very good battery for intents and purposes of an RV. This is technically labeled, the model is RV24, so it's a Group 24 class battery, and they try to trick you with the wording here. It's a reserve capacity and it gives you minutes and amperage. That's not what you're looking for when you're looking at a deep cycle battery. When you're looking at a deep cycle battery, you're looking at amp hours. So this is what I'm doing. This is a Duracell golf cart battery. Now there's a myriad of golf cart batteries out there. I want a standard wet cell because I'm not upgrading my charger. That's something maybe for another time. We're weekend warrior type people. We do take big trips once or twice a year, but we're not doing any serious boondocking. We're not going out into, Moab and camping for a week based on our battery bank. So a standard wet cell, which is what my converter's designed to charge, is fine with me. This is a Duracell GC2 golf car battery, just how they phrased it, how they labeled it for some reason. I got this at Sam's Club for $89 each. Now I had to pay a core on top of that because I didn't have batteries to bring them. But it's a solid battery. Now this is rated at around 215 to 220 amp hours. Now it's a 6 volt, so we're going to put 2 of them in series, and that's going to give us our 12 volts. So in doing that, we're going to have 12 volts, but it's going to be a massive 12 volt deep cycle battery with plenty of amp hours to, again, for my particular application, keep my refrigerator running for days if need be. That would never be the case for us, but I want it. This is like your entry level upgrade, short of getting one single 12 volt battery. But if you're upgrading your batteries, I would suggest creating a battery bank. Now, mine is a very simple battery bank. It's 2 batteries. As you wire your battery banks, when you're dealing with something like this at 6 volt, you have to wire the batteries in series, meaning the power is leaving the battery from the positive terminal here, and then this negative terminal is going to jumper over to this positive terminal on the other battery, and then leave off the negative terminal to the camper. So in that, you're going through one battery, then the other battery, creating a 12 volt big 12 volt battery. Golf cart batteries in particular are great for this application because of their massive amp hour. People pay $1,000 for a Battle-Born lithium battery and it only has 100 amp hours. Here's the rub. If you go to a 12 volt battery and you build a 2 battery bank, you wire them parallel. So it's positive and negative, jumpers over to positive and negative, and goes out to the RV. That's called wired in parallel. You're now, in this situation in series, we're doubling our amperage, or we're doubling our volts. When you wire parallel, you're doubling your amp hours. So if you get 2 12 volt batteries, deep cycle batteries that are 100 amp hours each, you're doubling them, and now you have one 12 volt battery with 200 amp hours. Basically works out to be about the same. I go this route because it's cheaper. $89. You're gonna have a hard time finding a 12 volt 200 amp hour battery for $89. The golf cart batteries tend to be more durable. They're larger. They have bigger plates in there because a golf cart draws a ton tons of amps on the battery. So this is what we're doing, and we're going to get into here how I'm setting this up. All right, so this is the area that we have to work in here. This is the old single battery box. I have turned off the battery disconnect on the inside, so there's no arcing, nothing happening here. This goes to the ground, the chassis. This goes to the chassis, the frame, which becomes the negative circuit for the whole camper. And obviously this goes to the battery disconnect first, and then from there out to all the DC circuits in the camper. So they came off the top of the post of the old battery. There were two self-tapping screws down in here that I just simply removed, and then this lifts right out of the way. Alright, so I got the larger Camco battery box that's going to accommodate the two golf cart batteries we have here. Obviously I'll put links in the description. The first thing I want to do, so you see here we have black is negative, red is positive, black is negative, red is positive. To wire these in series, we're going to basically hook up the RV wires, one to this positive, one to that negative. Then we're jumpering from this positive to this negative, and that's going to create one massive 12 volt battery. So the first thing we're going to start with our jumper wire. So I'm just going to put this on here. Oh, this is a 4 gauge wire. The whole coach is wired with 8 gauge. I could go down as far as 8 gauge, but since I had to buy a jumper wire to do this, I just got a 4 gauge wire to start in case for some reason I one day want to put something on a heavier draw. This wire is already in place. I don't have to worry about upgrading it. So we're going to kind of snake this around to try to keep it out of the way. One for the, well, we'll actually tuck that down inside there like that. One to keep it out of the way of the lid, but also servicing when we have to service the water levels. Now this wire doesn't matter, black, red, it's a jumper. So we're really not worried about color coding in this instance. I think that's going to work perfectly. If I could keep my big old hands on these little tiny nuts, that'd be good. Well, that didn't sound right. Alright. I left on the caps on the main post just for a little insulation in case anything happens to bump or whatever. It's just a little added layer of protection. So just snug. We're not trying to rip the lead out of the battery here. Just snug. Okay. Now, everything in my diagrams, a lot of times you look at DC voltage, red is positive, black is negative. And that holds true. All the DC wires you get, like these jumpers I have here for 8 gauge, what I'm using to hook up the battery monitor with, black and red. For some reason, the RV industry, they use white for negative. So just always remember, red is positive. From there, you know, whatever's left over, you put to negative. So this is our negative post here. Now what I want to look at before hooking that up is, I want to look how this lid is oriented. Doesn't appear to be any specific front or back. So that's going to go over it like that. Okay, so this little out notching here is where our wire is going to come through. So that's going to go to the back. So the battery disconnect is off. So that's not really a concern as far as putting this stuff on and having it spark and arc. So I actually have wing nuts for these. Just how the old battery came, so that's what I'm using. They're handy. Because these batteries feed them from the back, I want to try to keep this straight back towards the camper as possible. Even though it's a wing nut, I will give this a little snug with the pliers. You want good clean connections when you're dealing with electricity. A loose connection will cause heat, and that's never good. So now the positive end. That's very strange. I don't know what's going on with that wing nut. But what I'll do is when I'm done here, I'll go back and put the regular nut on here. I don't know if that, because the other one's a marine battery or something. I'm not sure why that's a different. But, so I want to try to route that kind of neatly as I can through here. It's not in any position where it's going to interfere with anything. But I want it, going straight out the back as possible. Okay, snug. I'm going to fix that. So now when you put the lid on, you got the lid going on, and those wires are coming in these openings in the back here, which also hope work for additional venting. And that's it. Now what I'm going to do with this, I put a couple of self-tappers in the actual box itself through the bottom of the plastic into the metal L brackets underneath there, the angle iron. But I'm also going to wrap this with 2 separate straps to really cinch it down tight, keep it from going anywhere. So as I push down on this and pull up on the strap, that is a very snug connection there. I'm going to cut this, leaving some slack. I'm going to cut it on an angle, and I will burn that with a lighter in a bit. So I had to get a new strap for this side as well because these are taller batteries. Therefore the battery box is taller, and I didn't leave enough slack. Evidently, lesson learned, always leave enough slack. Even this probably isn't enough slack. You always got to leave enough slack when you're doing stuff like this. I'm going to intentionally leave this one with even a little extra. Alright, so we have our 2 battery golf cart battery, deep cycle 6-volt bank built, wired up. Now I have a spot here. I'll be putting in a phase 2 of this little project, is putting in the battery monitor. So we're going to head under the RV and check that out. Alright, so we're back. You can probably tell from my shirt it's a different day. When I want to unpack my battery monitor, it has this shunt that has to go on down underneath between the batteries and any other negatives. There's a small little positive wire we have to hook up to this that's going to travel through the wire up here to power the battery monitor. Issue is that it actually doesn't come with that little wire. So I had to make a wire, and in doing so, by the time I finished that, it wasn't a big deal. It's been very stormy here in the Northeast, and rains and winds had moved in, so I had to wait to come out and film. So today kind of got away from me. It's getting a little dark out. I have my little cube light under here showing you where my hole is. So that's where this is going to mount. So this is the Ali battery monitor system. It's like $94. It does everything the $200 Victron does with the exception of Bluetooth. But guess what? I've heard many complaints that Bluetooth on the Victron ones, if you mount this inside at your control panel where most people like to have their stuff, when you're towing, it doesn't always reach the front of your vehicle. So My wife stops frequently, or I say, I stop frequently so my wife can use the latrine here in the camper. So in doing so, I will give me the opportunity to hop out, flip open this door, and check where we're at. I am confident with my 2 golf cart batteries and this 600 watt inverter feeding the refrigerator that even when it's running is only pulling 440 watts and doesn't run that often. I am confident we can do a 6-8 hour travel day and never have to worry about the batteries dropping below 50%. But it's critical that we keep an eye on them because you don't want to put a lead acid battery below that 50% threshold. It won't kill it per se, but you could start collecting, it's called sulfating the plates, which could make it die faster when you're putting a draw on it in the future. So just preserve our batteries, you know, regular maintenance, check the water levels, things like that, and we got to do our best not to drop it below 50%. So this monitor is going to enable me to do that. I have it right inside here with my water, my battery disconnects. If you watched the last video, you'll see how I wired up a light switch to disconnect the outgoing power from the inverter into an upgraded plug here. And my remote turn off and on, all that's kind of here in my bay control panel. So that's where I'm mounting this. It only comes with like a 6-foot wire, so I didn't want to have to. They do sell, but I didn't want to purchase another, you know, 3 or 4 16-foot extensions to get me back to the internal control panel. This is easy. I stop for gas, or I stop for my wife to use the bathroom. I hop out of my truck. This is driver's side. I flip it up. I can look at where we're at. Makes it nice and easy. So wherever it is you're deciding to mount this, find yourself, make sure you have plenty of clearance, and you want, it's a 2 1/8 standard hole saw. If you have a hole saw kit, you should have a 2 1/8. Some of the smaller, cheaper kits do not. If you only have one that has like 4 or 5 cups in it, I'll put a link to this one down bottom here on Amazon. It's like $8. So, and it's snug. So when you're drilling, you may have to come back out, because even an inch of 2 1/8 inches, which is what I was told I needed for this, it was still snug. I probably don't even have to put this wonky clamp on the back. So we have a clamp for this. Here's the shunt. I kind of dumped everything in one pile here. So there's a clamp. And a lot of people get confused how to use this clamp. They think they put it on with the prongs facing this way, and when they slide it in, it's going to somehow catch the wood. And that is how it's designed, but it has to go on after the fact. You can't put it on first and think, well, I want to slide it in until it clicks. It doesn't work that way. The other people think, well, I can put it on this way. You could put it on that way with the legs facing up, but that's not how it's designed. So the first thing we got to do is feed this little wire, the pigtail, through. Get this in place. Make sure you're looking at it. Once you push this in tight, you're not going to be able to really twist it a whole lot. So I'd make sure it's as straight as you want it to be, unless you're someone who don't really care about that type of stuff, as you push it all in there. Now I'm telling you right now, that is tight enough. See, it's hard to tell if it's perfectly straight because my outdoor shower spigot isn't quite straight. It was put on a little wonky, but it looks straight enough to me when I compare it to the stickers. That's tight enough. I really don't have to put this mount on, but for the sake of the video and the sake of safety or what have you, I am going to see. This is a pretty thick wood I'm putting it in. Man, this is tighter than Chris Farley's coat in here.
That guy in a little coat. That guy in a little coat.
All right, let's see if I can get this on with enough room. You got to make sure that wire's out of the way. I'm sure you can't see nothing with my big mitt in there. Okay, I got it on there. So for my installation, the wood here is actually thick, because I'll give Grand Design one thing. They still try to take pride. I mean, all RVs are made crappy, but Grand Design still tries to take pride. This is actual plywood, not particle board, and it's a little thick. I actually had to bend that slightly, bring the tabs. So if it's like this, I had to bring the tabs kind of out in order to get that on, so I had room for the wing nut, and it was still hitting in back there and grabbing. All right. Give this a few more twists here. I'm sorry you can't see a thing. I mean, I don't know why I'm bothering trying to film the back of this thing. You can't see nothing with my hand here. All right, that's in place. It's snug. So now I have this little pigtail here, and I have this, well, I think they said it's, oh, it's 6, I think they said it's, well, I got a very wide span, so that's probably just about 6 feet, 7 feet long. Now, I only need it to go, it's probably just about perfect for where I need it to go. Now, when I installed this inverter, I actually drilled a little hole back behind it that goes down through. So I'm going to hook this up to this pigtail and feed it through, and then we'll head under the carriage here. And it just pushes together. It's a little click lock mechanism. I got to try to feed this down. I want to turn this like this. I'm going to kind of bend it so there's minimal to try to make sure it can fit through that hole I drilled. It was only a 1-inch hole. So, and there's another wire running down through there, the negative cable. So I want to try to fish this back in here and feed it through and down, and then we'll go underneath and see what we got. All right, I got a hold of it. I want to feed it through. It's one good thing about being not quite human. My long Cro-Magnon arms. I was able to reach all the way under the carriage to there from sitting up here into the bay. So that's actually going to be perfect where I'm putting this shunt. So speaking of the shunt, let's talk about the shunt. So this is a pretty heavy duty. Now there's a couple of models of this, and they're only a few dollars difference. The one model is up to 0 to 100 amp draw. The other one is like 0 to 330 amp draw. The installation that I'm doing here, I'm never going to need anything above 100 amps. I can't draw more than maybe 8 amps max, you know, when it has it at a peak cycle for momentary reasons. If I draw more than 8, 9 amps through this inverter, it's kicking off on reset. So the 100 amp model is more than enough for what I needed. The 300 amp one, I think would be good if you were putting in a 3,000 watt inverter and you're looking to run your toaster and 2 air conditioners and things like that. I mean, pay the $5 extra and get the 350 amp shunt. I will never, ever, ever be pulling 100 amps through this battery, so I'm not really concerned about it. So this is what we have. Now, I don't know how well this Osmo is going to pick this up, if it's going to focus right. But that little green connector there, you see the white one on top, that's where that wire we just fed through is going to go, and there's that green guy right here. There's 2 ports there. You don't need one. That's the positive wire coming in. That's going to power this. So on one end of that wire, you're going to put a 5/16 loop. You're going to crimp it onto the end, and on the other end, you're going to feed it through the top here and tighten the screw down. Now, my intentions are to epoxy this to the inside of the frame. Once I do that, I'm going to have a bit of a time trying to hook up that wire after the fact. So I'm going to actually install that wire and this wire. Then I'm going to epoxy it in place so that if need be, I can always take the wires, this wire off. There's never any reason I'd have to take off the guy going to the green. And if I ever did for some reason, I can just cut it and then join it back together with a myriad of options. I like the kind of crimp options or shrink wrap connectors. Now, typically speaking, the inverter is fused internally. We have everything in the RV typically is fused. So they sell these little hunks of red wire with a fuse compartment in the middle, and you can put your fuse power of choice in there. So ideally, we would want to wire a fuse between here and the positive terminal where we're going, and I will be doing that. I actually do not have, I had a couple of spares from another project I did where I ran a DC outlet and voltage readout and a DC jack for my apnea machine down to my side of the bed, which is on the far end of the bay here. I bought like a 3-pack. I needed one. Can't find the other 2 to save my life. So we're just going to wire this straight with the wire I made. And later on, I'll go back. I will cut out a small area and wire in the fuse for that. So disclaimer, anything you're hooking up to positive power should have an inline fuse of some type between it and the positive power you're hooking up to, just in case something grounds out. You're not heating up wires or creating problems within the coach. You'll trip your fuse and you're done. So all that being said, this is in here. I'll bring this around. Trying to give everybody too much motion sickness. And you kind of see where it lives there. Now we're going to revisit this once everything's powered up with setting it up. So let's head underneath and see what we have downstairs. All right, we're back under the rig. So I kind of have this all wired up. I run into a few more odds and ends. And anytime we're doing projects like this, there's always going to be odd and end issues that you come across. So the wire coming from the battery had a 5/16 end on it. Because this is a heavy gauge shunt, I needed a 3/8 end, so I had to switch the end on that, which I had with the shrink wrap, not a big deal. And then of course I had the original wire I made was like stranded wire, and this hole is so tiny I had a hard time with that, so I went and I got a piece of heavy, it's like a thermostat wire, it's a solid gauge, actually came off a ballast in an old light fixture I had. It's probably like 18 gauge wire, but it's solid. So when I slipped it in there, it made a much better connection. And you need like a eyeglasses type screwdriver to tighten down that little green terminal. So I got a lot of slack here. I'm going to deal with all that in a minute. I just wanted to come over here and show you how it's set up now. One thing I noticed right away, the wire that goes up to the bay, in the bay the pigtail had a click lock. This does not. This literally just pushes in and can easily be yanked out. So once I get this fully installed, and I gotta button up and clean up all these wires and get everything up above the frame, I don't like anything hanging that could possibly catch something. I'm actually going to put a little drop of this acrylic glue excuse me, that I get at Home Depot. It's called Fiberfix. It's liquid acrylic, and then it has a little UV light that cures it relatively instantly. I'm going to put a drop of that on there to prevent this. If this does by any chance get knocked by something on the road, it's not going to pull out of there. So now this tube's a little older. Hopefully it's still got some good juice in it. The one thing about these, they're like 10 bucks each, and they do dry out quickly, and sometimes I've gotten them brand new out of the box and they refused to work for me. I had to take them back. It's a great product, but there's some quality control issues, I think, at the production company. Oh, okay, we got some flow. So you just put like a drop on that connector, flip on your UV light, hold it on there for a second or two. You'll see it smoke. And that's it. That's hard as a rock. That's not going anywhere. I'm actually going to use this to tack this up in place. Now the area up here I had wiped with some denatured alcohol. You can use regular rubbing alcohol. The idea behind that is it's a liquid, so it's going to clean off the dirt, but it evaporates quickly. There's no moisture left behind, so you're able to get and glue something or paint or do something to a surface without worrying about that moisture content. So I want to get this in relative position. Oh my God, my back. My chronic Lyme presents itself with very stiff joints and bones, and a lot of back issues. And one of the things it does is when I'm in a position like this, I'll end up having pretty nasty back spasms. So let's hope I get through this without that happening.
Doctor said I need a backiotomy.
Nope. Ooh, I think I got it. Try to put a little over this side. I just need like one more drop. I just need to hold it in place so I can then epoxy around it without having to worry about sitting here holding it for 15 minutes until the epoxy is fully set. Alright, there was a nice glob I just got out of there. As you tighten down the tip, it pushes out the tube and enables the handles to come out so you can squeeze it. Yeah, I definitely got a nice glob that time, so that should be good until I can get the epoxy on there. Well, everything that's going on in the row right now, we're not towing anywhere anytime soon, unfortunately. We had big plans, which we'll be going over in one of our upcoming videos. What our plans were and what our plans are now for this season. Let me tell you something, that's not going anywhere. I'm still going to put epoxy on it because, you know, elephant proofing. But that's actually not going anywhere as it is. So my mission now is I got to obviously do something with these wires, get everything up, secured, all that. I kind of loosened everything up to get me to where I could work easily. So just to review, we have coming off the positive terminal, we have the small wire going to the green port here, which is powering this wire for the readout up in the bay. We have coming from the battery to the B side of the shunt, and coming off the P side is the negative going to the chassis ground, and then that branches off to all the other negatives in the carriage, in the coach. So that's it, really it down here. I got to clean all this up, but you don't want to sit here and watch me do that. So let's go back up and check out the actual meter. All right, we're back up top here, and I wanted to show you this gauge and basically the quick setup of it. So right now it's already kind of done. I went through it to make sure there was going to be no snafus when I was filming, and it ended up being very easy. So when you come in here, right now it's asleep. Let me wake it up. So it's already been set, but essentially what you want to do is on percentage, when you first hook this up, it's going to pretty much say it's 0 because it doesn't understand where you're at. And then when you hit the AH for amp hours, that's the amps you're currently drawing, and then this is the total rating. So you come to your amp hour rating and you hit set, hold it in until it flashes, and then you program it what amp hour your batteries are. For me, it's 215 amp hours. Done. Then you go to percentage. Now this is going to probably say 0% because it has no programming. It doesn't know what it's expecting. So once you have your battery bank hooked up and it's set, say overnight charging to be 100% sure that they're 100% charged, you're coming here. This is going to say 0, and you're just going to hold set. You're going to hold set, and it's going to register and understand that you're telling it you're 100% charged, and that 0 is going to change to 100%. And then that's it. So you hit V, that's the voltage of your batteries. Amps, 30 amps you're currently drawing. You hit amp, again, there's your amp hours, and then percent, 100%. Now I'm going to unplug this from shore power and let it sit for about 5 hours, come out and check this and see where we're at. We've been running for about 3 hours now. I just wanted to show you the gauge. I've had everything off with the exception of the bay light comes on automatically when the door is open. So I'm getting a little extra amp draw because of the lights in here, but nothing major. So 3 hours, I'm at 78.3%. So there are some factors involved in that. Now the refrigerator, when it runs, and it'll cycle, you know, a few times an hour for however many minutes it runs, that'll be pulling about roughly 4 amps. And the actual, one thing I haven't mentioned through this whole thing is the actual inverter obviously has an amp draw from running. sitting there converting electricity even when you're not pulling from it. Well, we're always pulling from it. The microwave, clock, and circuit boards powered. You know, the hot water heater circuit board's powered. The refrigerator circuit board's powered. Even when it's not drawing amps, these things are drawing. So, but that sitting there alone will be drawing some power, roughly about 28 amps it draws. So across 3 hours, we've gotten just over a 20% drawdown. So 6 hours, you're at about 40% drawdown. Running at this, how it's running right now, which is there's no charge coming back to the batteries, you can probably go about 6 to 7 hours with this small, you know, cheap setup that I have going on here right now. So we saw from that gauge, across 3 hours, I've dropped around 25% roughly. So to take us down to that 50%, we're looking at about 6 hours. Now understand, this is worst case scenario. We are on a full amp draw with no hookups. There's no solar running. I'm not hooked up to my truck. Now when you hook up to your vehicle, you have a 7-prong plug that comes from the RV. That actually charges your battery as you're towing. So once you incorporate that offset to the calculation, you're easily doubling that tow time. Now I'll do a real world test on that, so I'm not just kind of throwing out numbers that aren't founded. I will do a real world test on that and compare apples to apples. How long after an hour sitting here, in a worst case scenario situation, versus an hour of me towing it behind my vehicle on a highway where it's actually getting charge put back to the battery. It's almost like the truck is feeding the power needed to run the inverter. Not fully, but it'll help offset it. So that inverter having its core draw down, plus when the refrigerator runs, or like I'll say, if my bay lights are on, the chip boards get powered whether you're using appliances or not, in the microwave, the hot water heater, the refrigerator, all those things are drawdown. So this is sitting here as a kind of a worst case scenario test, and we're still seeing easily 6 hours before our batteries start to enter any type of a, you know, concerning charge state. With it hooked up to the vehicle, I'm sure it's going to be easily double that. But I'll do some real world testing and follow up with you guys. For our next video, I'm going to be doing, it'll be a much shorter video than these videos, I'm sure, because there's not much to it, the Mopica propane tank level monitor. So it has 2 sensors that go under your tank. Now, this comes with these little aluminum feet. They used to come with rubber feet, and people were complaining that the rubber would split and it would be resting on the sensors, and that's not good. So I'm glad to see that Mopica actually is now upgraded to metal feet. But we'll get into all that in my setup. I actually have a ring, but we'll get into all that in that video. So check in probably next Sunday for that video. And it's a really cool device. There's a couple, like everything, there's a couple of caveats to it. But it's good to know exactly where you are your propane, because even the gas stop pressure gauges don't really give you an accurate reading of where you're at. And sometimes that can be critical, again, if it's cold out or if you're relying on propane for your air conditioning, or your air conditioning, listen to me, my wife walked out and distracted me, your refrigeration when you're parked. So that'll be in next week's video, so please check that out. And again, please like and subscribe, share if you find relevance to this, or you know somebody who would find this relevant. We're a smart channel, we're not monetized, but we have just been approved from Amazon to be an Amazon associate, which means any links I post to products in the video are referral links. It doesn't cost you a dime more, but if you were to purchase something using my link as opposed to just going directly to Amazon, we get a pennies on the dollar referral fee. But it's something that eventually, if they see us generating income for them, they'll allow us to have a full-fledged Amazon store where I can list things in categories: our photography equipment, our RV upgrades, you know, the top 10 things you should take with or buy the first day you have an RV, and all that type of stuff that you've probably seen on other channels. So thank you again for all your support. I hope you enjoy the content we're creating, and hopefully season 2 is going to bring some exciting new travel adventures and photography vlogs if the state of the world ever allows us to take this thing out of my driveway. All right, until then, we'll see you next time. Have a good one.